On to the next problem. A little different here. We have a 2x as the top bound. Other than that, it's the same as the last problem. So keep in mind that h prime, integral from a to the b, said, hey, integral, the derivative of the integral from the a to the x, f of d dt equals f of x. So in this case, there is a special case here that when you have a 2x, you got to multiply by the derivative of that top bound. So the derivative is really 2f of 2x. So it says, does it have a relative min or max or neither at x equals 1? So h prime has to first of all be equal to 0, and then if it is, then we're going to check to see if the sign changes. So h prime of 1 would be 2 times f of 2, because 2 times 1 is 2. F of 2 is 0. 2 times 0 would be 0. So it is a critical number. And so you want to check to see if the sign changes from positive to negative. So we've got to check the slope on either side. So if you check the slope at 0, let's say x equals 0, you have 2 h prime of 0 equals 2 f of 0. F of 0 is 2, so it's positive. And then we want to pick something in between here, like 4. So 2 times f of 2x, so 2 times 4 is 8. Well, f of 8, we don't know what the numerical value is. We don't need to, so you know that's negative. 2 times some negative number is going to be a negative number. So the sign changes from positive to negative, so it's a relative max. So continuing on, does the graph have a point of inflection at x equals 1? So we want to take the second derivative. The second derivative is the derivative times the derivative of the inside. So it's going to be 2 times f prime of 2x times 2, because there's a 2 in there, so it's 4 times f prime of 2x. So h double prime of 1 would be 4 times f prime of 2. So 4 times 0, but that slope, 4 times the slope at 2. The slope at 2 is undefined. So it's a possible inflection point. Then we need to check the slope on either side of it. So, because we're looking at the slope of f prime. So the slope on the left side is negative. The slope on the right side is negative. So the slope does not change sign. So it is not an inflection point, because the slope does not change signs. And then it's finding h of -5 and h of 3. So put it in your integral back at the original function. H of -0.5 would be from 3, or sorry, from 6. Can't read it, it's blurry. To 2 times -0.5 is -1 of f, and h of 3 would be from 6 to 6. Well, 6 to 6, if you do an integral of that, is 0. It's nothing. the integral from 6 to negative 1 would be the same as negative 1 to 6 of f using the opposite sign. So from negative 1 to 6, we're looking at the area of this whole thing. And that's going to be our h value. So we have a triangle that is 3 by 4, so it's 12. Half of that's 6. It's above the x-axis. And then we have a half a circle that has a radius of 2. So the area is 4 pi. Half of that is 2 pi. It's below. And then so it would just be the opposite of 6 minus 2 pi, or negative 6 plus 2 pi if you want to simplify. You can leave it unsimplified. The last part of the question asks where the function h is increasing and concave down. So we'll take this as two parts. So increasing is when h prime is positive. So our h prime was f of 2x times 2. So h prime equals 2 f of 2x. So where is that going to be positive? So you start looking at values. It's where it first becomes so the interval on which this is positive, where f of x is positive, it's above the x-axis here all the way to here. But we have to account for this 2x, and so when you're plugging in numbers, if you plug in 2, you get f of 4, which is negative. So we have to think about, what do you plug in to make this part of the function equal to 2? Well, that would be x equals 1. And what do you plug in to get this equal to negative 3? That would be negative 0.5. So from negative 0.5 to 1, we are increasing. And we need to find out then where the second derivative is negative. So the second derivative we said was h double prime before f of 2x. And so we need to look at, we're looking at, for f prime of 2x. So we're looking at where is the slope negative. If that's negative, then in that interval anywhere, then we're talking about it's increasing, because we already have our interval, and concave down. So we're looking at just our interval right here. So we're going to look just here. Well, from x equals negative 1/2 until you get to x equals 1 is where we are negative. It's also negative at x equals 2, or right up until there, but we are just looking at this interval. That's a little bit trickier question with that 2x in there. So it's increasing on this whole interval that's concave down from negative 1/2 to 1. Or, negative 1/2 to 1. on the whole interval there up until 2, it's also, but that's not part of our original increasing. So on that increasing and concave down, -1/2 to 1. Again, the 2x makes it a little bit tricky.